rectangular coordinates. So it's a little bit of graphing involved here with this stuff. Nothing just too strenuous, but it's a little bit of graphing. And when we talk about graphing, we talk about ordered pairs. Ordered pairs, x comma y. We're seeing those. It's an x coordinate and a y coordinate, and we draw those ordered pairs. We plot them on what's called a Cartesian plane, but that really doesn't matter that it's called Cartesian. That's just giving some guy credit for it. It's the XY plane. You got an x-axis, you got a y-axis. X goes left to right, y goes up and down. Then you have 4 quadrants, and the way they number the quadrants is they start in the top right, call that quadrant 1, and then they go counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. And the accepted way of doing that is with Roman numerals. That's what I'm using there. That's not used very much these days. You see a whole lot of Roman numeral things happening with things. Super Bowl is about the most common place you see them. They still use Roman numerals for that. That'll stop probably for long. Yeah. So it may never be Roman numerals again. All right, so let's talk about the ordered pairs in each quadrant. So over here in quadrant 1, what kind of x values do we have over here? If we're going toward the right, are they positive or negative? They're positive. So our coordinates on this side have positive x values, and then the y values would be going up, so that y going up would imply that they are positive as well. So all of the ordered pairs in quadrant 1 have positive x's and positive y's. Okay? In quadrant 2, what changes? Well, all the y's are still up here, so that's still in the positive side of y. But the x's now went to the left. So to the left is going to be negative. So all the ordered pairs that are in quadrant 2 have negative x values and positive y values. Okay? And then we go down here to quadrant 3. Well, the x's are still negative. If we go down, that makes the y's what? Negative as well. So quadrant 3, they're both negative values. Okay? Quadrant 4, x's are positive and the y's are negative. Okay? What that does for us, knowing that, is it would help us tell where a point should end up. So if we look at an ordered pair and say where is 6, negative 3. Well, the x value is positive, the y value is negative, so I know it's in quadrant 4. Because of the signs on it. So that you wouldn't have to plot that point and then decide. You could look at just the signs of it and know that out of that. So that's the hope that you would understand that that's what's going on. Okay? So let's look at some points and practice plotting them on a coordinate plane. Real easy thing here. So let's plot. On the coordinate plane. Okay. Make myself a little ruler here. Draw a semi-straight line. The left hand doesn't seem to want to do that very well. Alright, so we'll call this example A. And we're going to just put a bunch of points here. So I'm going to name those points. A is at 2, 5. B is at negative 3, negative 5. Point C is at 0, 3. Point D is at 3, 0. Point E is at negative 4, 2. And then point F is at 0, 0. So we're gonna tell where these are at, on the coordinate planes, like what quadrant are they in, or if they're in a quadrant, and then we're going to plot them on the coordinate plane over here. So I'm going to draw myself a little coordinate plane to that. If you got graph paper, great. If you don't, I'll show you what to do. You just want to draw off little tick marks for each line. You know, just kind of try to be consistent in how far apart they are in all directions. Not easy to do. If you're artistically challenged like I am, graph paper is your friend. That'll be far enough. Okay. So before we even plot them, let's say where they're at. So point A, where would it be located? What quadrant? Quadrant 1. I'm going to put that out to the side. And then I'm going to plot that point. Point A is at 2, 5. So I go over to 2 on the x-axis and up to 5 on the y-axis. 1, 2, 3, 4, 5. And that's the point A. 2, 5. Over 2, up 5. What quadrant would point B be located in? 3. Double negative. So we know it's in quadrant 3. So when I plot that point, I better end up down here in the bottom left, right? That's what quadrant 3 is. So go to negative 3. So I'm going to start here at 0, 0, and I'm going to go left 3 and then down 5. 1, 2, 3, 4, 5. And that's going to be point B. So I'm just going to put the letter beside it so we know which one's which. Okay. 0, 3. Is that in quadrant 1? It's riding the fence. It's a fence straddler. So what's it really on? It's on the plane. It's right here, right? There's where 0, 3 is. Point C. What axis is that? It's the y-axis. So that's where we'd say it's at. Because you can't say it's in quadrant 1. Because it's just as much in quadrant 2 as it is in quadrant 1, right? It's a fence straddler. So we tell them, well, what fence is it on? It's on the y-axis fence. That's where it's at. 3, 0, point D would be where? The x-axis is at 3, 0, so I'll go right 3, up 0. So there's point D, and it's on the x-axis. Where that's located. Point E. They've got a negative x and a positive y. Quadrant 2. Negative 4, positive 2. Point E. Point F. Where's it at? Right there in the middle. What's its name? Origin, yeah. O-R-I-G-I-N. Origin. Okay. It's a special name. It's a point. It's not on the x-axis or the y-axis. It's on both of them. It's not in any quadrant, so that's why it's got a special name called the origin. Okay, so make sure you know that. Not too bad. All right, now let's talk about a formula that we need to know. The distance formula. Distance formula used to find the distance between 2 points is what that's for. Okay. Obvious, right? For the distance formula to work, you have to have 2 ordered pairs. Because if you did find the distance between 2 points, my high school kids, if I ask them, what's the shortest distance between 2 points? Do y'all know the answer to that question? A straight line. They don't know the answer to that question. So I worry about this generation of kids. They don't know the answer to that. They want to Google it. And I'm like, guys, no. Just no. It's a straight line. So we take the x values from our 2 points and we subtract them and we square that answer. Plus, then take the y values and we square those. Those numbers down there at the bottom, like that x2 and X1 just tells me what ordered pair they come from. So like you would have two ordered pairs, X1, Y1. My handwriting's getting worse as the night goes on. And then X2, Y2. You'd have two ordered pairs. So take your X values, subtract them, square that answer. Take your Y values, subtract them, square that answer. As long as you're putting X values together and Y values together, you can't screw it up. Because that squaring takes care of everything. Because what kind of number do you always get back when you square something? Positive, always. Got to keep that in mind as we're working that. So let's look at an example. And we might have 2 points. And we want to find the distance between, this is example B, I guess. The distance between -2,5 and 12,3. -2,5 and 12,3. And, you know, plotting them on the coordinate plane is great and wonderful, but that doesn't help us find the distance. Or maybe it does, depending on how you learned how to do this in geometry class in high school. Because there's a way to do this and turn it into Pythagorean theorem. Because distance formula is Pythagorean theorem. But if you got the ordered pairs, just plug it in the formula. D equals square root x2 minus x1 squared plus y2 minus y1 squared. And then we're going to take the square root after we find all those numbers. So I'm going to plug in the stuff I know. So the stuff I know is that 12 and -2 are the x values. I'm going to plug those in. I'm going to put the 12 minus -2. And then I'm going to square that answer. Then I know the y values are 3 and 5. 3 minus 5. It would not mess it up if I did 5 minus 3. It works out okay. I put it as 3 minus 5 because the formula says x2 minus x1, y2 minus y1. And I always, if I flip-flop those, somebody always says, well, why'd you change that one? And you can, and it doesn't mess it up. You just got to be careful on your signs, you know, when you do that. Okay? All right, so working this out a little bit. We got 12 minus -2 turns into 12 plus 2. It's 14. So that's 14 squared plus 3 minus 5, -2 squared. I'm going to work that out. So 14 squared. No, that's 14 times 2. 14 squared would be 196. And then -2 squared is 4, right? Positive 4. Be careful, don't mess up the sign. And then we add those together and we get square root of 200, which we could approximate with calculator. With the graphing calculator, to do a square root, you want to hit second, and then over here on the left, there's a button that says x squared. Right above that, in the blue writing, it has a square root symbol. So you hit second, x squared, and that gets you a square root symbol. And then we type in 200 and hit enter. Give me an answer. 14.14213,562, and I bet it keeps going forever. I know it does. So I'm going to round to 2 decimal places on that. Okay, so 14.14. 14. Not 4114. And I'll just box both of those in there. There's the exact answer. There's the decimal approximation for that. Distance formula really is that. Know that formula. Let's plug it in. Okay? Know that formula and plug it in. I usually do give some of the formulas on tests, like when you come and take a test for this, the first test, I will give you the distance formula. If you do the practice like you should, you'll know the formula. You won't even have to look at it. You'll know it. But I do go ahead and post it so that you don't have to fret over not knowing the formula and then miss every problem because you were so stressed out over not knowing a formula. But anyway, You'll memorize it anyway as you're doing practice for this, because I know everybody's going to do some practice for this. Right? Right. Next formula that we'll deal with is the midpoint formula. The midpoint formula finds us a point. It's an ordered pair answer. The midpoint formula is halfway between. Okay? Used to try to find halfway between, home and the coast so that you had somewhere to stop. You try to get halfway, stop, eat, get out of the car, stretch your legs, and then drive the other half. So that midpoint formula out of that. So if you looked at ordered pairs and a midpoint formula, you take the average of the two x values, and then you take the average of the two y values, add them up, divide by 2. That's what I mean by take the average. Add the x values, divide by 2. Add the y values, divide by 2. You get an ordered pair as an answer. This is not like distance formula. Distance formula, you're going to get a number. With midpoint formula, you're going to get an ordered pair because you're looking for a point. An ordered pair place, a position of midpoint. Okay? So, let's get an example of that. Example C. Let's say find the midpoint between 8, -4, and -6, +1. I think midpoint formula is easier than distance formula. Okay. So to get the x value for a midpoint, we're going to add our x values. 8 plus -6, and then divide by 2. To get the y value for our midpoint, we're going to add the y values. -4 plus 1 divided by 2. Okay? And that's going to get us an ordered pair answer. So when I work that out, -8 plus 8 plus -6 would be 2 divided by 2, which is 1. Okay, so we'll get an x value of 1. And then -4 plus 1 would be -3. Divided by 2 is just -3 over 2. Ordered pair, midpoint, 1, -3 halves. There's rhyme and reason why I set them up separate like that, because we're about to do some problems that like stretch it a little bit. Get you a little higher on the totem pole of mathematics of that. By setting them up separate like that, it really makes the next part easier. Maybe not easy, but easier. Okay. All right. So the next thing that kind of comes up in this is, what if they give us the midpoint and one of the endpoints and say find the other one? Okay, so they've given us one endpoint and the midpoint and say, okay, what's the missing endpoint? So we're looking at problems that are saying finding the missing endpoint. Okay, so this is what brings it up to a little higher level of mathematics here. So taking it from just plugging into a formula to actually applying the formula to get somewhere with it. So if they give you one endpoint and the midpoint, which is what they're going to have to give you for you to do this, and they're going to say, okay, endpoint -6, +12, and a midpoint of 8, -2. Find the other endpoint. That's what they're going to tell you to do. Okay? We know that midpoint came from a midpoint formula. It came from adding the x's and dividing by 2, and then adding the y's and dividing by 2. Okay? That midpoint came from that. We know part of that. we know that the x value of the midpoint is how much? It's 8. So 8 is equal to the x value. I don't know. I don't know what the endpoint that's missing is. But I do know the other endpoint is -6. Okay, so I've set up this equation. So we're getting into some real math here. An equation to find the other endpoint. So we don't know one of the x's, but we know the -6 is an x for an endpoint. We don't know that other endpoint. So, but we know the midpoint's 8 for the x value. So we set it equal to 8. And then we work this problem. Well, I could multiply by 2 to get rid of that because they're dividing by 2. The opposite of that is multiply by 2. Cancels that out. That gets us 16 over here. And how could I get x by itself there? My green's not showing up too good. I may need to change colors there. Change that to a blue. See that pretty good. How do I get that 6 over there with the 16? Add 6 and 16. That's right. So the opposite of that would be add 6 to 16, and we get 22. There's our x value. Let's find the y value. So what do we know the y value is for the midpoint? It's -2. They gave it to us. What do we know the y value for the other endpoint is? We know it's 12, so that'd be y plus 12 divided by 2. So we get this equation that we can set up that the 8 and the -2 that they're equal to, this 8 came from the midpoint. This -2 came from the midpoint. That's where that's coming from. And then we just work that out. The steps are the same. Multiply by 2. -4 is equal to y plus 12. And how do I get y by itself now? Yeah, the opposite of adding 12 would be subtracting 12. And that'd be -16. So the missing endpoint is the ordered pair 22, -16. Okay. If you'll go back and look at that again as you're doing those problems, there's not a whole lot of those in there, but there is some of that. So if you'll set them up like that, use the midpoint formula that you have, and then plug in the things you know, okay, and set up those equations. And if you'll set those up, makes them really, really easy, okay? All right, just got 2 more examples, and we're out of here for the night. I know it's been a long one. All right, so let's graph an equation. Example E. Y equals 4x minus 1. Okay? Does anybody know how to graph that already? Or remember how? Y equals 4x minus 1. By graph that, I mean put it on a coordinate plane. Good. That means I get to teach you how. It's easy. No matter what kind of equation you've got, you can always create a graph by picking x values, plugging them in, working them out. Okay? So what you can do is you can create yourself a table with x and y coordinates with ordered pairs. And then all you've got to do once you get them worked out is plot those points, and you'll see what the graph looks like. Okay? So a lot of times when you just get an equation, they say graph that thing, what x values do I pick? Some good ones to kind of as a default to go to would be like -2, -1, 0, 1, and 2. Those would all be great x values to pick for that particular equation, or any equation, really. They're a good foundational thing. They're right there around the origin, so we're not getting really big, having to draw a huge graph. We're just going to get a picture of what's happening there at those x values. And what we need to do is plug those x values in to the 4x minus 1. So we're going to do 4 times negative 2 and then subtract 1. So that'd be negative 8 minus 1 would be negative 9. And then I would do 4 times negative 1 minus 1. Which would be negative 4 minus 1 is negative 5. Then I'd plug in a 0. That'd be negative 1. And then I'd plug in a 1. And that'd be 4 minus 1 is 3. And I'd plug in the 2. Work that out. 8 minus 1 is 7. Now I've got 5 ordered pairs that I can plot on the coordinate plane, the way we did with the very first example in class. And what we should see is some sort of pattern develop in the way the picture looks. We can see the pattern in the numbers there, hopefully, that we're going up by 4 each time. That's that 4 in front of the x. That's what's causing that. So I'm going to plot those points. So I'm going to negative 2, negative 9. And then I'm going to negative 1, negative 5. I'm going to 0 and negative 1. 1 and 3. 2 and 7. 2, 4, 6, 7. We notice those points all kind of line up, right? Make a straight line. I'm going to draw a straight line through that. We got a line there. Does anybody remember doing the y-intercepts negative 1 and then you count your slope up 4 over 1? Remember doing that? That's another way to graph that. The table is kind of what they're after in this section. But if you remember graphing 4x minus 1, using the negative 1 as the y-intercept and count your slope up 4 over 1, up 4 over 1, that's where those points are coming from. But they're really after, get some ordered pairs and plot it on the coordinate plane, because they're not always going to be linear stuff with this section. The next example is not linear, so it doesn't work that way. So the ordered pairs really is the best way to go about these, because they're just going to throw random equations at you and say graph them. I would pick these x values. They really work well for most all of them. Okay, so pick those x values, or like on the Blackboard homework thing, it may give you some x values and say plot these points for, and it'll get, I have x values already put out there for you to do. Okay, yes sir.
So basically, did you have to really do all of this because you just went up 4 off of 1?
No, I wouldn't have had to do all that. Yeah, but with the next example, what I was really showing is plug in the x values and work it out, because that really works well for a problem like this. Maybe they have x squared minus 4. Can't do that the same way, but you can plug in the x values and work them out and get points. So that's the reason I did it with all that work, is because it works on this way too. So it's like more of a universal, always works this way type thing. So if I pick my x values again here, I'm going to pick negative 2, negative 1, 0, 1, and 2. That's going to give me a good idea what this graph looks like. And I'm going to work those out. So I'm going to have negative 2 squared minus 4. And I work that out, and I get how much? 0, right? And now plug in negative 1 squared minus 4. Negative 3, good. Now plug in a 0. That'd be negative 4, right? And I plug in a 1. That's negative 3 again. And plug in a 2. 2 squared is 4. 4 minus 4 is 0 again. Okay? So I got some ordered pairs out of that. So no matter what the equation looks like, you can pick some x values, plug them in, you'll get a picture of what's going on. there. So when I go to the coordinate plane and draw that and try to, get a picture of that going, of that particular graph, those 5 ordered pairs are going to help me. So I'm going to plot those points: -2, 0, -1, -3, 0, -4, +1, -3, and then 2, 0. Those are those ordered pairs out of that. What this ends up doing is making this kind of shape. It's not quite a V. It's a little kind of rounded more at the bottom out of that. But it makes that kind of shape. But the ordered pairs really are that. If you wanted to get more ordered pairs, you could pick more X values so you get more of a picture out of that. With your graphing calculator, it does have the graphing function on it, and I'll show you how to do that real quick. If you're going to try to graph something with the graphing calculator, there's a button there that says Y equals. You can hit Y equals. I've got some stuff already typed in there, so I'm going to delete those. So I'm just moving my cursor to those and hitting clear, and it'll delete them. And then, if I wanted to graph that first example, 4x minus 1, I would type in 4, and then to get an x, you can hit alpha and then find the green X if you want to, or there's a nice little button right here that says X. Put it there because it's used a lot. Okay, 4x minus 1. And if I hit graph with my calculator, it's going to draw me that line, which is really nice. So I know that I got the right picture. It's kind of where that's at. Okay. If I wanted to get those ordered pairs that I did, I could hit the trace button and type in, well, -2. What's that Y value? There's the -9. Notice down here at the bottom that I've got a -9 as the Y value. It tells me the ordered pair down there at the bottom of my screen. Your graphing calculator that you guys can get has the same thing. If I did -1, I just type a -1, hit enter. There's the -5 that I found by plugging it in. 0. There's the -1 I found by plugging it in. 1. There's the 3 that I found by plugging it in. And then +2. There's that 7 that I found by plugging it in. So the graphing calculator can do a lot for you. If you go back to, oops, press the wrong button there, to Y equals, and I want to look at that graph for the x squared minus 4, that last example that we just did, I would hit X and then squared and then a right arrow to get out of the exponent minus 4 and hit graph, and I'm going to see that kind of U shape happening there. And I can again hit trace and then type in the X values that I wanted. It was already on 0, so just automatically put that there. It may or may not always be on 0 when you hit trace. And if I could do -2, plug that in. There's that 0, -1, 0, 1, 2. I could do 3, 5. 5 gets off the screen. You can't even see the point, but it's at Y is 21 when X is 5. But you can work those out there. So the graphing calculator can kind of help you make sure you got the right picture going. Also can help you get the ordered pairs out of that as well. So there's a lot of plus side of that graphing calculator on that part. All right, so that's all our material for tonight. My suggested problems, and this may seem like a lot, and if you know anybody that had me last couple of semesters, they'll say it seems like he's giving you tons of work to do, and I am, but I promise you the people that are successful in the class do at least some of each type of problem. 1 through 93 odd. Do you need to know all 40-something of those problems? Probably not. But I would make sure I do some from each little subset. Your book really does a good job of breaking it up into subsets. Like you'll see a set of problems. It'll have a set of instructions above it. And then there'll be another set of instructions and another set of problems. If you'll do, a couple from the front, a couple from the middle, and a couple from the end of each section, because it builds in difficulty. Easy at the bit, and middle is average, and then the harder ones at the end. If you'll do that with each section, then that'll help you. And then if you have trouble with a particular subset of those, then that's the ones you would want to focus on and really get some more help on those. On R2, page 17, 1 through 47. And I say the odd ones because the odd answers are in the back. That way you can check to see if you got them right or wrong. You guys have been in math classes before. You know that's kind of how the books work. In high school, they worked that way. They still work that way now. 1 through 43 odd for for the R3, those sections. And then on 2.1 on page 178, 1 through 59 odd. Those are what I would call suggested problems. And with the suggested problems, I'm not taking that up for a grade or anything, but it will help you get prepared for the Blackboard work. So if you'll do some of that before you do the Blackboard, the Blackboard stuff, it's like a quiz. It's going to grade it when you work those problems, but it's more of a practice type thing to get you ready for the exam over this material. Okay, so if you'll do some of this, it'll get you ready for that, so you don't have to spend quite as much time laboring over those types of problems because you've already done some like it. You got an idea what you're doing.